Thank you, Alexander. Thank you very much for the invitation. So Alfred Bühler was invited me, but and Alexander sent me a very kind email. I was very honored to be able to spend a summer day with you here in Gießen. So my talk is about delivering ICT for biomedical research, and this is a difficult problem. I don't know if anyone has really managed to do it. Grade A from the clinical bioinformaticians praising that you're doing a great job, but we've been trying to do this so I've been doing this at the CSC for 20 years, and CSC has been doing cloud computing for quite many years, and I would say that the Elixir is the reason why we have a scientific cloud service in Finland. So this story is about that, how do we do this service, and how do we try to keep the service users happy, what we are doing, what we expect them to know what to do. So this is a talk about users, really. So CSC in a nutshell, so we are a rather old operation. So we were founded already in 1971 to make the first supercomputer that was bought in Finland as a service for the people. So basically, the state bought a computer, but they needed people to provide it as a service for science and the other purposes wanted. So it's not that different from what we are doing today. So we did it 40 years ago. We were privatized, a state-owned company in '92, and now from the beginning of this year, because of all the different legislation related to how you are allowed to buy computers in a public project, universities also became our owners. So we are owned by the state and the university, but we are a company. We are about 280 people. So with the summer employees, more than 300 now. We are non-profit, means that all the funding that we get, investments and the service funding, we try to turn it into useful things for science, culture, and other things. There are about 60 people with a science background, like myself. So I have a PhD in structural bioinformatics. We have 2 offices. So the main office is in Helsinki, and then we also have a site in Kajaani, which is a former paper mill. So this is a kind of a interesting recycling story, that what is the common thing between computers and paper. So really the common thing is that when you run the computers or when you make the paper, you need a similar infrastructure in terms of, for instance, electricity input. If you run a paper mill, you need a very stable and very high voltage electricity infrastructure. So when the paper consumption went down, so those sites in Finland that used to make paper, so quite many of them have been converted into data centers. So Google bought one of them, and we are renting one of them from one of the big paper mill factories, now turned into some sort of energy companies and things like this. Anyway, that is in high up north, and it is a very energy efficient and blah 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 sort of thing. Well, if you imagine, so if you need to put a lot of concrete somewhere, it is a really big CO2 emission. But if you have the concrete and the halls and the electricity settings already in place, so why not reuse it if it's possible? I think it's a good story. CSC hosts the Elixir Finland node. So like in Germany, so we have few biologists, so we can't cover the knowledge base of the whole country. So we have a consortium with the biocenters and the key institutes in Finland that work with the node. But CSC is the single legal entity. It means that we can make contracts with the European hub, Elixir. So this makes things quite simple. In the German node, so there's a network of nodes that need to agree between them, but still there's a single representative body, if I understand it right, and Alfred Bühler is heading this and handling the negotiations. Finland is 5 million people. It's like half of Berlin. So you you have to put this into a context. So we are a small country, and having a centralized structure to interact with the European structure makes sense. So we focus scientifically on biomedical data, and our partners are the Finnish Institute for Molecular Medicine and the National Institute for Health and Welfare. We are focusing in Europe in cloud computing, authentication, authorization infrastructure, training, and having reference biological data sets computationally available for the scientific environments that people want to run. So I'll tell quite a lot more about this during the hour. And CST, since we've been around for 40 years, we are an existing e-infrastructure collaborator for any European technical projects. So the Elixir Finland node in the context of Europe, so forming these, having a single legal entity but interacting with the national specialized organization. So as all the nodes in Europe, so we're trying to build the local country bioinformatics capacities throughout Europe so that we could meet the data management and data processing country. So each country has the same problem. Basically, Elixir is that countries can rely on each other a little bit so that we have colleagues that we can talk to. Probably any problem that you face here in Germany, so somebody in some country, somebody has faced the same problem, so then you can exchange experiences and solutions about this. So the hub counted that there are about 180 institutes involved in Elixir through the nodes, through structures like this. So it's a rather big organization already. Collaboration agreements are signed between the nodes, like the and the hub, and this collaboration agreement give a framework to add on services the node would produce also for the European setting, not just the country setting. Okay, so this is where I come from and the organizational backing. And the talk or the actual content of the lecture is 3 parts. So I'm also always talking about like the services and then users, the consumption side. So sort of biomedical use cases benefit from the services that we are producing. So I'm approaching in the same order as you saw the organizational packing. So I'm first talking about what CSC does, the local community. We are hosting the Elixir Finland node and we are doing bioinformatics services. Then I'll try to explain the specialization of Finland in Europe, so what the cloud and AI and training mean in Europe. And then I'll end the talk to the European picture. I'm also the co-chair of the Elixir compute platform with Steven Newhouse and Ludek Matishka from MBL EBI and Elixir Czech node. So I'm trying to explain what we are trying to do in the European sector. Okay. So this is not only about biology. The biology is rather big customer segment already. So I counted from the 5 million population have about 1,200 active bioinformaticians in the whole country. I don't know if this measure can be generalized, but it is true in Denmark as well, similar size and fit. Any point given of time, certain proportion of the scientists are computationally inclined and they serve their colleagues in the local laboratory. So for a population of 5.6 million in Finland or 5.8 million, you have about 12 to 1,300 bioinformaticians crunch the data for the research base of the size. I don't know if it's true. Anyway, so we also serve the research institutes and organizations with generic IT services. We provide backing for the universities to track the student credits and the courses they have taken. We provide the libraries IT infrastructure so that they can run the library information system on top of our infrastructure. We maintain the national internet or the network backbone, and we connect the Finland to the. So we do all sorts of IT stuff. So with 300 people, you can do quite a lot of things. So an example of users that the Elixir Finland node is very interested in are the biobanks. So in Finland, there are 8 registered, in the legal sense, biobanks. So 2 of them are nationwide, so they cover the whole population, and 6 are more clinically oriented. So they have been set up around a particular medical question, like a blood bank or a certain type of cancer. So services can be grouped into 8 different areas: scientific computing, networking, identity management, training, and other services. If you think about somebody like a biobank, so what they would want from an IT, they always want to pick several of these, and they would expect somebody to come into their operation, listen to what they do with the blood samples and sequencing them, and translate their need into these, then integrate the services and provide a solution. So this seems to be what people expect. But the IT people, they go to a highly specialized, experienced biomedical operation. They listen to what they do a live translation of that into technical components, integrate the components, come up with the service solution. This seems to be the expectation many times. Obviously, this is not feasible, and you need to, in that sense, you need to go there. You need to go to a biobank. You need to listen to what they do. You need to try to understand what the problem in the data management is. Then try to come up from your infrastructure perspective what you could do for them. But it's still a dialogue. It depends. It takes quite a lot of time sometimes before you converge what you can deliver, and if it's useful for a particular problem at that stage. So biomedical science itself is not easy, and the computing side is also very versatile. So we run different types of computing services. Traditional part is, of course, the high performance computing and the capacity computing. There are also flavors like graphics nodes attached to the compute clusters. Now, the recent thing, the virtualization of some of these physical capacity. So this is the service that seems to fit many of the specialized software stacks biomedical science flavors want to use. It's not easy to give root access to compute cluster that you provide as a service. Security, serious security issue. But in the cloud, so that gives more flexibility for those people who know what to do, set up the scientific software as they want to do. This is why we have went into cloud computing. Of course, it's possible also to bring your own computers into the paper mill. There's a lot of space there. What I've been driving quite a lot is that there would be a more uniform infrastructure in terms of compute and storage. On the HPC side, there's emphasis on the floating operations per second, and I've tried to push it more into how many operations can run on the disk per IOPS side. And we have recently defined that our storage services are also having at least 5 different flavors in terms of capacity, capability, acceleration, or some feature like stability. So if you think about like EBI, I'm Dario in the back row. So if EBI would say that, okay, you can deposit your data, EBI, it will be here for at least 2 years. So nobody would do it. EBI has to say that this is permanent archive. and it's a real difficult promise to make. You have to be really committed to providing this service. But this is clearly what is needed. You need to have these archives that map out to the world on which you can build on your, for instance, data analysis services. You need these stable storage services as well. And if you just put the data into a stable archive, it's not much use. It has to be integrated. This is where EBI is clearly the leading. Okay. So the number of projects that we have at the moment in biomedical sciences is about 300, and this corresponds to about 1/3 of the projects running at CSC from all sciences in Finland. Typically, the statistics that are gathered in a computer, like CSC, they focus on the flops. So these 30% of the projects, scientific projects, they only consume around 10% of the CSC capacity. But then it's difficult to collect statistics that would be comparable to the compute usage from the storage at the moment in a uniform way. So this picture that we've been showing to the funders is not completely realistic. That's why I brought the number of projects, because there the biological sciences is the biggest one, and it is growing as well. So in bioinformatics, there are many projects that the computing service providers use as examples. And one of the cases that benefits from the traditional computing is structural bioinformatics, so protein structure and function. So this is also bioinformatics, but it can use all the capacities that exist around Europe, for instance, European written cloud infrastructure. So if you want to fit drug molecules into a protein structure, that is a simulation. Basically, it's not transferring huge amounts of data across Europe, like in some data analysis applications. It's more about like you get a library of chemicals and you try to simulate them for them inside a protein structure. This is a traditional simulation. You could say that this alone could be scaled to use all the compute capacity in Europe, because the amount of protein structures has grown 100-fold in the last 15 years or so. So if you fit every feasible chemical into every protein, that is likely to be important in a biological pathway. So you could create an immense computational problem. This has been a little bit used on the e-infrastructure side to justify that, okay, that we are serving bioinformatics. Well, they are, but this is a computational problem from bioinformatics that fits the traditional design of the computing services. So this is something that we need to tackle in Elixir, that the diversity of different data analysis and data management problems are appreciated on the technical side. My understanding is that the audience here is mostly technical, but bioinformatics aware. So this is a quite key thing, that you would actually appreciate the spectrum of data management that comes from biology. Biology is a huge area of different computational needs where the uptake is sometimes not that easy to make as in areas like physics, where computing is an integral part of them. So, the education. Going to education, so we also run training in order to tackle this problem. So how to train the biologists to use the electronic infrastructure. So we organize something in the range of 50 to 60 training events, workshops a year. So training is so it is also a focus in the de.NBI network to run trainings. And running trainings and workshops of this kind I think it is the best way to meet colleagues from different sites and from different disciplines as well. Training is a very good service for the community. We are also recording There are materials available from the Finnish site on the internet without access control. So you'd say that this is a form of open data. I don't know if anybody has the energy to look at like this recording afterwards. Quite a tedious thing to do, but we'll see what can be. For Elixir training in particular, so we have organized things like metagenomics or bacterial data analysis course recently. We are doing so variant analysis, variant calling is a topic of interest. So for instance, GATK software package, which is some sort of a state-of-the-art in genome analysis. So we'll have a GATK course coming later this year. We had the previous one in 2016. We have specialized training for people who want to set up the virtual servers on the CC cloud services. And we're collaborating with Elixir also on the data side, so the data carpentry. But as I said, so we are not that many people, sciences, so we need to bring in the trainers to Finland to run a course like data carpentry. The CSC is a place that the researchers in the local network know that, okay, they run a lot of trainings and let's look at what they have oncoming. So it's a good place for the trainers also to collaborate. So they come there, we set everything up, you just come and do your stuff, and that's easy for the trainer. And yeah, so one more thing. So Elixir runs a European training portal called TESS. So this is a place where Elixir will be gathering good training materials. So this is a place to look for training materials related to bioinformatics. Okay, so then another aspect. So we're funded mostly from the national sources. So we have to deliver services in Finland. So we have a place where the bioscientists can come to CSC pages and they get a lot of services. So everything that we do is basically available without the cost for the users inside Finland. So any researcher can come to CSC and set up an account and get a huge variety of bioscience services from us. So of course we can't scale this to Europe. So Finland's funders are not happy if we sort of would try to do this with the Finnish funds without having some sort of terms agreed with the European setting. So, okay, this is just an example then. Okay. So if we would open all these services, it would require an agreement that for instance, the Elixir Hub wants to set up a particular CSC service for European access. This is also where Elixir can help us a great deal. Of course, we have studies and data sets that are unique to Finland that will be part of the European whole. So one example here is the freshwater seal genome that has been recently created. And the idea here is that really, if we want to understand the effects of single nucleotide variants in a genome, and if you have a small population like the freshwater seal, which is unique in the world, staying in one lake for 10,000 years, has different types of eyes and brains and teeth as the other seals in the ocean. So you could see that if this seal population has some genetic variants that are apparent that result in the different eyes, when you compare them to the general seal population. So this sort of information is a unique source that comes from Finland. It will be shared through Elixir for the greater community. Okay, so these are the things that we do inside Finland that may or may not have impact on the European setting. Now I'm going to move a little bit more into what sort of services we are doing for the Europe. So Elixir membership has grown. This should be 2017, but so Elixir now has I think 21. Is it 21? 21 members. Yes. So it's in 20 states and EMBL who are members of Elixir. So compared to large countries like Germany, France, UK, Finland is 10 times smaller than UK, for instance. We have to really think about what are the services that are credible in the European setting that would come out from Finland. And the specialization that we have chosen for the node, they sort of they derive from the strengths of the organization hosting the node, CSC. So we have set up the cloud service. So basically, this is something that CSC is good at. So running computational services, but we have brought in an additional layer, so trying to virtualize everything, so making it easier to mold the scientific software and data management environments into kinds that the biologists. They're also focusing on identity and access management. So this is sounds technical, but it is a requirement that you recognize people electronically in a good enough way. If you can recognize people when they come to the internet, that I'm Alexander from Gießen, but do I trust this person, which it just comes with the user credentials. So how much can I trust that this is really Alexander? So this electronic identification is a key feature that those service providers who host sensitive data sets would like to consume. This is part of the infrastructure, really. You need to be able to identify people electronically to a certain level of assurance. The access management is a different infrastructure. Identities, or recognizing people and then giving them access rights to services or data sets. These are two different service infrastructures. Yeah. Architectural sense. So this is actually quite important. In the past, people have tried to do this both at the same time, but that doesn't scale if you go outside your own organization. So we have separated these two different infrastructures: so federated identification of people and federated authorization of people. So we've implemented this, for instance, the national setting again. It's easier to do things with the institutes that are close to you. But the National Institute for Health and Welfare, so they have implemented the Elixir AI solution to control access into the biobank samples and data. Practical implementation of the technology that we have developed within the node. Then we run the training courses that I introduced already. So I introduced the whole training portfolio, but we are the Elixir setting focusing on bioinformatics courses, of course. But we are not restricting bioinformaticians. But if they want to go to a parallel programming course, be my guest. We would actually even encourage that if you want to go to a different, what the different expert bubble is doing. So I think it could be fun. And then we have, as an emerging service, software services. So we have a software environment called Chipster that is basically built on top of R and bioconductor. So there are around 200 different bioinformatics tools that have been bundled together into a single virtual machine release. We're doing a release of this virtual machine every half a year or quarter of a year. So this virtual machine should be portable to the other clouds, as the Elixir Finland cloud as well. This is trying to support all the different phases of the research process with these services. So we try to go into helping researchers to make a plan how to produce and collect their data, how to analyze it, how to store it, and how to publish it. We're trying to see the whole picture of the researcher's life cycle. This is more complicated again than what it looks. I just bought this one technical picture here. So So we're working with a project called Sequence Initiative Suomi. So they're trying to sequence quite a lot of things and connect the sequence information with the register data in various national bodies. So they are creating the data mostly in the United States. What we would need to do is to return the data back to Finland, couple it with the proper authorization and authentication tools, and then make the data available on the cloud. The ePouta is the brand name of the CSC Sensitive Data Cloud, but the real purpose of this data management expertise has been that the projects have been creating data so that they have gotten a permission from a biobank for a certain biomedical question, sent the data samples over to sequencing facility in the US or in the UK, and the data is there. They collaborate with the international colleagues to analyze it. And once the paper in Nature is out, then the data stays around. Officials are not happy. These samples come from a Finnish biobank, and okay, there's data in the US. I don't want to hear about it. I want to hear about it. You know how? But basically, the exercise is more or less about how do we, if we create data, various sites around the world, how do we return it back into the own country or the computational facility? So we're trying to enable this process, because this happens as we speak. Many research labs, not in Finland alone, so they are figuring out how to produce the data. Then in the worst case, you end up with a 200 kilograms of hard drives being shipped to you by UPS, and then they contact us. What I do with it? And we said, okay, you send them back and let us download the data directly from the site of creation. This would be the thing that we are trying to promote, that actually when they send the samples over, they would already have figured out that they would download it directly to CSC Cloud. That would make things much more simple. Some of these data creation decisions, they are worth €1 million. All that money, sort of the value of the data creation investment goes down as quickly as you see the price of the sequencing going down. So you really have to be well timed with your data creation. But this is just like a future look. So I'll speak more about this picture later on. But just to say that this all maps into the European collaboration as well. So this is a quite big picture. So I would just like to highlight here that in Europe, there's a service called the European Genome Archive. It's been around for quite many years, that accepts submissions of human data that has been consented for research purpose. So each country, they have this challenge of how to manage the human data, and not everybody is happy of sending all the data over to EBI to be hosted. So many of the countries, they want to set up their local solutions that would be interoperable with the central established European archive. Basically having the data not leave the country, but having the description on the data compatible with the central archive. Still holds quite a lot of data that might be needed as part of the data analysis pipeline. So I think EGA is about 4 petabytes at the moment. It's not easy either to replicate the whole archive into the country. Germany might want to do that. 4 petabytes still and growing is quite a big part. Spain has decided to do. Okay, so one of the clouds here that would sort of be able to interact with large data sets like the EGA, or could be the cloud in Finland, ePouta. So I'll have a little side story now. So tell a little bit how it came to be. It's easy to say that, okay, we have this fantastic service running, but I'd like to give you a sneak peek to 2010 when we had nothing. Okay, so the first thing, which is quite complicated, is that what is the business model for running a cloud for scientists? Scientists are famous for not having any money. So basically, if you are a service provider for a cloud and you ask for the researchers, I have this fantastic cloud, just pay. Okay, they might have a little money. They might want to go to Amazon to run a small server test. But as soon as you enter the scientific computing, then you really start consuming a lot of money. But you don't have money. So this is the problem. So basically, what you need a funder. And then in a sense, when the research funder decides that, okay, let's do this fantastic liver disease project. So what they decide is also for the researcher or the user that, okay, they will, when they have the data, there will be a data analysis need created. So basically, what we've been trying to do is to get the research funder to see the whole picture of the research service provisioning for the use cases. But as you see, when you have three bodies here and not just like bilateral buy and serve kind of thing, then it becomes quite complicated picture. This is the business model we have to live with. And this is so in order to prove that you're useful for science, you thus need to get this thing started, and that is difficult. So we needed biomedical users who trusted us enough to build the infrastructure service concept at CSC so that we could convince the funders that this whole ecosystem work. And I put some pointers here. As you see, there's one in Germany. So one of the use cases that we interacted early on was Burkhard Rost lab. So there was Laszlo Kajan, who was brave enough to work with Finns in setting up our cloud. Sorry. You can see that usually we have like 20-minute presentations. I've spent about 40 minutes now. It's the double normal time. So yeah. So anyway, in 2010, so we started this with the Molecular Institute for Molecular Medicine. So basically, we had something that was not perhaps a cloud yet. So we had blades, and we had a private network link to the institute. So basically, we just virtualized a small cluster and delivered it through optical private network. And a year later, when this worked, we got new users, but we couldn't afford to draw a line, optical private link to Munich. So we had to resort to VPN, but this worked as well. So we bought some new equipment with the funding that came from the funders and expanded, for instance, the virtualized NFS system. I would say that the virtualized NFS system that came from this exercise is the most important service component that I would never give up. So a shared file system between the virtual machines. This is a very popular. We got a new funding decision because we said that this is a really good thing, and we expanded the system. And eventually in 2013, we bought more scale outs and placed them into another data center, the paper mill. And when we got to this part, so we already had quite a lot of equipment. So even though it's a cloud, it's infinite, it will scale up. Some of the equipment started to be 3 or 4 years old, so we started to be a little bit nervous. So we had more than 20 use cases. So then in 2014, we updated the National Research Infrastructure Roadmap. And we got the most important groups, including Burkhard Rost group, to speak for us. So they, oh, sorry, it doesn't show very well, but it says that we asked from this 20 plus research groups to give us a feedback. And we got a very high score overall. We used this feedback to make the case for the research funders. And this is how we got the cloud at CSC into production. The production means that the ministries actually took it into the annual contract. So then we have other funding sources that just the grants, the funders. Still, users, you go and ask for them from money. So, I mean, it's so difficult, really so difficult. I don't know what is the solution here. It's always a partial funding that you can actually get from the actual research users of this research. I'm not saying that our funding model is solved, but this is how we've done. So there's basically just 3 places where you can get funding. You can get it from users, you can get it from the service providers, organizations, or you can get it from funders, ministries. So just these 3. There's nothing else. Money doesn't trickle down from magical. That's it. But that's where we are today. So basically, we run 2 major flavors of the cloud. So Airpota is you could say that it's a personal computer for organizations. So it is completely isolated network towards the CSC machinery or the centralized computing facilities. So there's no other traffic in the connection to our side. Then we also run that like Amazon style infrastructure as a service you can access through the internet, and but the equipment that is virtualized more geared towards scientific computing, not in optimizing that you can crunch in as many tenants as possible in a single piece of hardware. So what changes here really is pointed in the arrow. So if you run a traditional cluster and you set it up with a scientific software for various sciences, so you provide a really good service, then you can't tailor. But if you have the virtualized environment, you could have templates like the Chipster as a starting point. Then you can tailor still further from the user perspective. But if it requires administration work, this is probably something that some of the research groups don't think about. So the postdoc's time is free. It's not free. This is about division of work in this. But this is what changes, in my view, at the very, very high level. So anyone basically in Europe can get access to these. And if you have a research collaboration with the Finnish group, it could be a free project. But you can also negotiate your way in with money. So we have a price list as well. So, okay, this is a more technical picture also that shows the integration to the personal computer for organization. That you have the administrator administrating the virtual machines that have been allocated to your organization that are delivered through the private network and integrate into your local cluster. This is the basic kind of that. So from the research group perspective, it is the easiest if you already run a cluster where you have your data management pipeline set up and you manage your users in a normal way, login into the cluster. Then you extend the cluster towards the ICT infrastructure. You need to figure out just a few questions, and then you get it's sort of a good service for an IT administrator working for a group of active professors in bioinformatics. All right, and the last 15 minutes of the talk then about how do we participate with these services in the Elixir Compute and the European setting. So this is the Elixir structure. So basically Elixir has 5 technical platforms, one for compute, one for data, one for tools, one for interoperability, and these are sort of connected with a training portfolio covering these areas. So Elixir implementation is driven by scientific use cases, which are Mirai Metagenomics, rare diseases, human data, and plant sciences. This is the Elixir structure we are implementing as part of the Accelerate project in 2015-2019. Elixir distributed infrastructure services in Europe are presented here. So of course the heart of this are the data resources. So Elixir is running important data resources like European Nucleotide Archive, the Genome Phenome Archive, Protein Data Bank, and so forth. These are the core of Elixir, but of course you can add many different things on top of that. We from the Finland perspective, we are focusing on the compute and training sites to support the consumption of this data by the local research. The compute platform, which I'm responsible for, is focusing how we could integrate existing compute services from the 20 countries and EMBL in order to support the consumption of the data resources. These are, whether we are successful in the technical integration of the services that come from the various nodes, measured if we can produce something of use for the scientific use cases. So this is how, at the European level, the development is driven. We try to pick out services from different nodes, integrate and open them, and then try to get the Elixir colleagues working for the scientific use cases to use the things on the compute platform and ask if it was useful. And if they say it was, then we have some feedback. So an example of a use case for data analysis is running a Spark-based Mirai Metagenomics software pipeline at the Elixir Finland cloud and using the Elixir on-location authorization services to identify the users. Just a brief introduction to metagenomics, if you are not so quickly. Basically, this is about microbes and microorganisms that are everywhere. Basically, in this room, when we came to this room, it had its own microorganism environment. While we have stayed here now for almost an hour, so we have changed the metagenomics markup of this room. It's been estimated that if you go to a hotel room and if you stay there for 30 minutes, you alone will change the microbe environment of the room so much that you could potentially be identified. Quite an amazing and invisible world. So they surround us everywhere, and really the genetic information that consists of the microflora, microbiome is not very well mapped. So people are gathering samples from oceans, soil, and hospitals and sequencing this. It creates a lot of data, and many of the groups who gather these samples, they are not experts in computing. So it's a beautiful use case, I think, for Elixir, how to support the data analysis and data movement from. So in Norway, there's a web portal for a metagenomics specialist of MetaPipe, and you can log into this service using the Elixir AI. You send your data into a software pipeline that runs Spark job in the CSE cluster. Then it returns the data, the portal, which gives it to you for download or visualization. Rather simple. What is Elixir AI? Because I've been mentioning this so many times. So basically, I told first, so a reliable identification of users is needed to access some services which consume stuff or some data resources require this. So you can create your Elixir identity today if you wish. It doesn't mean that you create a new username or password pair. It means that you would link, for instance, your home organization identity to the Elixir AI system. Basically, it gives you a unique identifier this way. And you can link also other identities like Google, Orchid into the same identity. And the Elixir service providers would use that identity to verify that who you are. So they would ask from an identity provider like your home university, that is this person really Alexander? There's no new username or password created. We would use the existing ones and we would give them a measure how good they are. So this is what this is about. We have at the moment, we have over 300 home organization like university identity providers working with the system. We have close to 800 users and 30 registered services that have said that they are happy to rely on this. There was a training in collaboration with Elixir Germany. Okay, so back to the Mirai Metagenomics use case. So basically from the compute service provision viewpoint, so we need to transfer the data from the portal into the site of the computations that is seen by the nodes that have been given for the portal owners. So at the moment, the portal is in Norway and the worker nodes, they are in the Elixir Finland cloud. So basically data moves between these two sites. So we have done this, it works. But the question is that will the Mirai Metagenomics data analysis portal stay a collaboration between Finland and Norway, or will it become a European one? So I would say that it has to become a European one. So what we have basically demonstrated here is that the portability of the software has been reached to a certain level, and it could be sent to the other sites like the European cloud. So this is the user view then. Of course, the user doesn't know where the workload goes. And this is fine as long as the data that is being shipped around and analyzed is not under any serious legal scrutiny. So as I said, basically we have, where the Elixir has gone now is that we have really demonstrated that if there's specialized good service, data analysis service in a university, so the software underlying that service can be encapsulated, containerized, and the load, at least part of it, can be moved to the other site. So the recommendation really is for the bioinformaticians is that they would think about this from day one. If you need to scale up, but it is so much easier if you have thought about the containerization of your software workflow from day one. That is a really key thing to think about. Still, the problem that we haven't really figured out is the business. What is the way to authorize use of cloud resources that reside in different countries or in Europe? And even though this was made for one particular use case, we think this is a generalizable lesson to learn from. Maybe the hot potato, so the use case for sensitive human data. If there's a data archive somewhere with sensitive data that people would like to access computationally, so how do you do this? So this reflects now back to this complex picture of the European Genome Archive. So I've highlighted there are two things that we provide from Elixir Finland. So first is the secure cloud. The other one is the data access federation tool called REMS. So this is part of the Elixir authentication authorization. So the concept really is that you have researchers with research groups, you have data resource controllers, data controllers like the EGA who have data sets which they have described. These descriptions of the data sets that are potentially available can be deposited in this tool called REMS that we run from Elixir Finland. The REMS tool and the data resources and the researchers, they are all connected with the same identity federation. Basically, all these services reside within the Elixir AI. So when a researcher wants access to a particular data set, they would need to apply for access, agree to the terms of so forth. Same goes for the research group members. And once this has been done, the data controller gets the information from the service, and they can approve the application when an entitlement these researchers have been identified to have the access right to the dataset gets recorded. It's recorded as part of your identity, attribute attached to federated identity says that you can access particular dataset residing in the service. Then the research groups can start to access. This is the basic workflow, the REMS tool, which is part of the Elixir AI. When we connect this workflow in the human research data support workflow, so we would need the EGI to work in such a way that data can be transferred after the access permitted trusted cloud. Say there's a virtual machine in Elixir Finland cloud, data controller trusts enough that if a person secured the access right, that they would send data over there. We need to guarantee things like that the data is destroyed after for the particular purpose. So the roles here is that there is a user or requester, there's a data access committee that is responsible for the proper use of the data, there's a trusted cloud system, and there's the data service provider. So for one thing that needs to be done is that the access permissions stored in AI systems need to be synchronized with data. There has to be a way to read the permissions from the archive so that a data download or streaming can be initiated. And there has to be a resource, of course, available for the user who has acquired the access rights. So this is what we're doing in the work package 9. So I went through this very quickly. I'd be happy to answer more questions on the discussion side. But basically what we are trying to do with workflows is of this kind. So the demonstrator will be out, I think, in October. Then it will be in the same stage as the Mirai Metagenomics workflow, as I said. So this is all very new. But the key goal is to increase availability of biomedical data for secure computational access. And we would leverage the Elixir AI federated identity system in order to achieve this. It's a very tough job, and there's a lot of requirements that come from the evolution, such as the General Data Protection Regulation. And this is all to protect the privacy of the individual. So this is my second last slide to say that there's Finland, there's Europe, but we have also quite a lot of collaboration between the Nordic countries, Sweden, Norway, Denmark, Finland. But we are also working in the same area. So all of these countries have the challenge of how do we manage the human data in a proper way. We have a fairly large initiative called Trygve 2, funded by Norden or Nordic e-infrastructure collaboration. So this is about 600 person months for the 2017 and 20. So the collaboration opportunity, I think. Of course, we need to work with the European e-infrastructures to understand all these problems. Surprisingly, little funding directly from the e-infrastructure projects to Elixir, but still we are a partner in many of the important projects. So EGI Engage, Helix Nebula, European Open Science Cloud, and ARC and ARC2 projects. So these are our main projects where the compute platform is collaborating. Okay, that was my story. I went over time by 2 minutes. I hope it's okay. So I wanted to bring some faces to the people who actually do the work. So I'm a biochemist, and I need a good technical coordinator. Otherwise, I couldn't be talking these things. And I need people like Mikael Linden who can really fit a complex policy and technological framework like AI in biological problems. And I have excellent European colleagues from the compute platform. So these are just co-leads, Steven and Ludek, but there's a lot of good people in the Elixir community, and I'm really happy that I got this talk about what we are doing. Thank you very much for your attention. Any questions?